We will start with the overview about the tools for optical measurement. And the next thing would be some basic ideas about light and lens, especially for measurement. Light and lens is really important. The exacter you want to measure, the more important is to decide the right light and lens, because measurement depends on edges, and edges depend on light and lens. This is what we should have in the background the whole day. If you have not good edges, or edges which might change due to light constraints or something else, the measurements will change. If you going to subpixels, you will see it even more. The first step will be measurement in pixel. And after we done some measurement in pixel, we will then see how to do calibration. Calibration is the basic stuff to do measurements in a unit, like millimeters, meters, or whatever. It depends on what we want to measure, or what the result should be at the end. And if you have a look to these steps, then we will have a shorter look also to measurement in 3D, means in the point cloud or in a 3D profile. And of course, at the end, we also will have a look to some measurement examples. For all who attended the yesterday webinar, they know how to install Ivision and how to use Ivision, and especially also you know about demo projects. So if you don't know it, I recommend to have a look to the webinar from yesterday. It should be online today in our YouTube channel or on our new website, the Vision Academy. The Vision Academy is a website which will guide you to machine vision solutions, especially, or of course, based on Ivision software and on the supported hardware of the Ivision software, which we discussed yesterday also. I recommend to have a look to the webinar from yesterday if you don't have this background. Else you know it, and we can use this at our basic discussion. Of course, we will we started this Vision Academy. That means it will grow over the year, over the months. We will put small videos to all kind of tasks you have to do, starting from installing a camera in the Ivision software to how to set up the right light and lens, and also how, for example, to do some measurements in millimeter, how to do measurements in pixels, or how to find colors and all this stuff, which will be handled in our different seminars this year. So this is always, if you need a short help based on a video, and of course for each video you will find also a project file and this kind of stuff, so that you have an easy access to the contents to learn the Ivision software. So I would skip the first step about EVT. I think most of you know EVT. We are located in Germany, and we have a subsidiary in Korea. So we have also different distributors around the world and integrators. If you want to know more, I recommend the YouTube video about EVT, which goes through all this stuff, especially, maybe I mentioned it, the different versions of the Ivision software. The versions of the Ivision software doesn't depend on the hardware, it depends only on the license. And of course, I mentioned it yesterday, for each license, you can add each other tool you need. So you simply use the demo version. You can make with the demo version your solution, and then you see, okay, I can start or buy the basic version, the standard version, or I need maybe the professional version or the 3D area, or maybe I use the basic version and maybe the deep learning tools or whatever tools you need. So if you are not familiar with this, or you need some help, simply let us know. You can always reach us on support@evt-web.com. And now let's have a look to the Ivision software. And of course, so let's start with measurement. I assume you have installed the Ivision software. The links for the Ivision software you've got with the seminar invitation. And after all, I hope maybe you attended yesterday's session, then you know how to make an image, and of course also how to make a project. Today we will focus on measurement. That means, of course, we need the image capture tool, and we need, because we want to measure, we need to find edges. Edges are the basic of measurement. After you have some edges, you could use the basic geometry to do some measurements, or you also can use some complex tool like the free caliper to do the measurements. Of course, for everything, but it's true, it was true yesterday, and it's more important today. We have all these kind of filters in the software, as it's normal, but at the others, on the other hand, you should also take care, as I mentioned, the edge is the basic of the accurate, the perfect measurement. And if you have a bad edge, the measurement is not good, or let's say you have a not good measurement or a bad measurement, however you want to name it. That's why I really recommend, first of all, to adjust the light and lens situation to get the right solution. And today we use this small screw part. And as you can see, it's really difficult to illuminate it. We'll do most of the measurement on the white part. If you do it in the real image, so this is a real image. If we run it live, we will see, okay, this is a live image. And as I mentioned yesterday, we start always with a new project. I explained it yesterday, so I simply generate this project. Let's say we name it today 2D webinar measurement. Yes, measurement, that's enough. So, and the first thing is the software will start up, and we will be at our basic setup. We have our toolboxes on the left side. We have the program editor and the camera viewer. So let's think about the measurement. We will do some measurements on live images, but that you can follow up and do it step by step by your own. You will find a nice captured image sequence in our standard installation. So if you go to our system folder, it was a little bit fast. you will find the system folder in, with show directory, and then you go to projects. And if you downloaded the software, you don't see all this stuff. These are the additional projects which you can download and copy into this project. Especially today, I will refer to the 2D area examples, and especially to the 2D area example measure and calibration later on. But for the first step, for our own tests and to show you how it works, we use the PC local. The first step would be, so you should have PC local installed, and in PC local you find the images folder, and there we will have a look to the training section. So for today, as long as we don't use live images, we use this training folder. Therefore, if you generated this project as I showed it before, you simply copy this training folder to the folder, to our project folder 2D webinar measurement. So if you go to the project folder, and here we are at 2D webinar measurement and images. Of course, it's empty, it's a new project. So we add this folder, training 1. And to store our images, which I capture immediately from the camera, I would make a new folder, our screw folder, or however we name it. I think this is in your choice. This is now an empty folder. And the first thing what we want to do is what we did yesterday also. We generate some images which we use later on for our test when we don't want to always handle with the camera. So the first thing is we capture an image from the camera. This was the wrong camera, as we can see. So we use this camera here. And of course, this is the right camera. This is our part, which I want to use. So the first, we are capturing it. And then the next step would be, okay, we save the image as I showed it yesterday. We save multiple images. So let's see, continuous with timestamp. Of course, if you want to measure and you want to test this measurement with a good accuracy also on stored images, in this case, in despite of yesterday, I recommend to use the PNG or the BMP extension to have an uncompressed image. If you want only to test it, or as you see with the demo images in the training section, there it's a JPEG. JPEG has a major advantage. It's compressed and you don't need so much space. So we have only maybe 5 or 6 images. Let's take PNG. So we say screw holder G. And we want to have a distance between the timestamp, so we make an underscore. So, and if we finish this, we can run it. And if you have a look now to our folder, you see our first image from the screw. Now I would move it a little bit around and run it again. And I move it around and run it again. And once again, this is number 3. And I rotate it on 90 degrees. And let's say I move it in this direction. Now we should have something. So now we don't have it. So this is, as I explained it yesterday, this is the demo reason. In demo, the I/O operations are not always operated. So if you do it single stepwise, you simply return once again and you have it. So now we have 2, 4, 6 images. This is enough for today. Of course, what we can do anyway, if we want to store more later, we don't have to do it again. We say capture. We name it capture and save, which explains what the program is doing. It simply captures images and saves it. So let's make a new program, and we name it, first of all, we do a capture. In this case, we capture it cyclic from file, in this case from the complete folder. And the interesting thing is now, as I showed it yesterday, each time the tool is running, we get a new image from the file. And so you see it's the same as I did it before from the camera directly. The only difference is now we grab it from the file. Of course, we cannot change the image parameters right now, but we can do all the programming stuff with these images without handling so much with the camera itself. Or if you have the camera connected to the machine, you don't have to run the machine. You can simply program on these images. So let's say now do pixel measure. So let's say we want to measure something here in this image, and of course we start with there are always different ways to do measurements, and depending on what you want to do, there are easy ways to do it or more complex ways. Not always the easy way not always works. Let's say in our case here, we want to measure the distance from left to right of this part here. In this case, we could use simply our caliper. Why the caliper? Because you don't have to think so much. This is a ready-made tool to do measurements. It looks like a caliper, and it works similarly to the caliper. The only important thing is now you attach the caliper to the area where you want to measure. You give him the search area, and of course you can press test, and then you see, okay, he measures the inner distance. We don't want to have the inner distance. Why does it do it? Simply because sorry, because we are looking for a dark element, but right now our part is bright, and we have to select the bright element, and now we get this result. So immediately we know it's 99.64 pixels. As you saw it in the main program, we said do pixel measurement. That means now, yes, we have 99.64 pixels, whatever it means. Of course, if you only want to compare things, you could use a golden part. That means you have one good part which you measured on a measuring machine, and you can tell your system now, okay, you know, this 99.641, this is the right value. That's what I need. Maybe you say plus minus 1 pixel. And then you can start with your production unit. Of course, it's still green, and if the pixel size is bigger or low or smaller, you get an error. So we measured. All tools work in subpixel. That's why you get this point whatever. And what happens now? That's also why I moved the part. If I run it, you see, okay, we don't measure because we can only measure if the part is at the same position as it was when we did the measurement, because the tool is not moving. And of course, in most projects, your parts are not moving so much, so that you don't have a problem with this. But in many cases, the parts moving more or less. So that means you have to adjust your measurement to the part. It's recommended to do it always, then you are not dependent on the very precise positioning of the part to do the measurement. Anyway, it's a good thing if it's possible. If not, then you are not dependent on it. So the first thing is what we want to do today is that we want to follow the part and do the measurements on this part. How do we do this? Therefore, we open the calibration part. So, of course, right now we don't want to calibrate, but one major issue or one major step is calibration depends on coordinate systems. And what we want to do is now we want to move the coordinate system to the part so that we can follow the part and do the measurement. I will explain how it works. Let's start and we show our basic coordinate system. Therefore, we can use the standard scale factors. We only use the draw axis. And if you run it now, we see this is our basic coordinate system. And it's 1-to-1, 1 pixel is 1 unit. It's not calibrated, we're still measuring in pixels. So, and the idea of all the tools here below is these tools belong to the coordinate system. The caliper which we used belongs to the coordinate system. If I trained it here, it's relative to this coordinate system which you see here. As long as coordinate system is here, the caliper stays here. So the simple idea behind of everything is we simply move the coordinate system into the part so that all the tools follow the coordinate system and therefore it follows the part. There are different ways to do this. So if you have a part which is always at the same position because you are on a tray and the tray goes in a position and it maybe moves one millimeter plus minus, I think you don't need it. You can simply work without this addition. If you cannot position it so precise, maybe you have a rotating table where the part is anywhere on the table, or you have a belt where the part is moving under the belt, then you have to do this. That's why I use it, because the simpler case is easier to do. You simply can eliminate what I now do, and it works anyway. So let's start with a non-moving part, and then doing the rest. So of course, let's use an image capture from the camera and see. So this is our part, and of course I can move it a little bit. So it could be anywhere. So let's say this is the test position because it's on your tray and it's always on the same position. This can also be simulated with the file. If you don't use this cyclic, if you say fixed file. So there's no difference. The only difference between cyclic and fixed in this case is, and the camera is that the camera always captures a new image and you have some noise. So if you have this one and the part is nearly always in the same position, then you can do exactly what we did before. We simply position it, the caliper to the position to where we want to measure the stuff. We select, of course, bright because we want to have the bright distance. And now maybe we also want to adjust the tolerances, 99 plus minus 1 or 0.5, whatever it fits better. Oh, might be good. And Now, each time we measure, so if we run the software and we go under the tool you see here, okay, it's really measuring all the time. And now you see also slightly the result is moving. This is due to noise from the camera. And that is one of the reasons why I said you have to adjust the light and the lens. The better the edge is, the better your result are. So how can we see it? We could use, in this case, the communication tool to print something. And in this case, we do the print. We print the diameter, the distance, the distance of the caliper tool. So, and if we run it now, we will see, okay, we have somewhat stable, not somewhat, we have a stable result of 99.40 whatever. Depending on the pixel size, we can calculate this later. We know now this is hundredths of a millimeter, I would assume. That means if you use this value, you say 99.4 plus minus 0.1, then you have this hundredths of millimeter accuracy. You don't see the millimeters, you see only the pixels. The next step will be we calibrate it in millimeter and then you see the millimeters. But this is the first thing, and you see the difference between the stored images and the real images is only that we have a noise. If you have a fixed file, then we don't have the noise. Now we can see also, of course, if we move the part a little bit. So that's exactly what I said, as long as it's not moving too much. So now we are too far away. Now we are out of the measuring position. You have to bring it back. And now we see we have a different measurement, and simply because we want to have a straight measurement and we trained it for an angle. So if you can guarantee that the part is very stable at the same position, you don't have to think about it. If you don't know it, it's always valuable to do this position adjustment. What we can do right now is, of course, we can go back to our capture. Let's save this one here. And we go back to our capture and save. And we simply save another quantity of images from this position. So we make a folder and say still position. Okay. And we say part place. Let's use a JPEG. Let's use a JPEG file. And what we can do now is, then you will see it fills up here a little bit. We run it for a while. Okay, now we are lucky. We didn't interrupt it by the demo version. So let's see how many images we have. We have our still position, and we have no images here because because we didn't change to this position. So let's see if yes, still position. Okay, so now we run it for a while. Now you can see, okay, it runs through it, and we stop it. And if you have a look to it now, you see, okay, we have, let's see how many we have. We have roughly 146 images. Now we can do also the still, and you see, of course, we have some not stored images, but that doesn't care. So in this case now, we can go back to this measure pixels, and instead of capturing the images from the camera, of course, we can simply change to the still position, and we run it now. And you see, of course, now the values are changing because these are all different images from exactly the same position. These are really different images. Else, if you have only one file, let's say we select any of these here, so we can run it now, and you see now the value is exactly fixed because it's always exactly the same file. This is one of the reasons why at the end you should store a real bunch of images before you start doing the programming, that you really see also the differences of different images. That means the modification of light, lens, and structure, and whatever. So simply think about either you do it at the machine all the time, if you can, or you simply store a lot of images and you work on this bunch of images. So now we have these images, and we could do later also some statistics with these images. Let's simply say we use still position, and we can run it here, and we see the tolerances between the different image captures. Let's store this, and we use do pixel measurement with movement. We make a new program, and of course we do the same stuff as before, where we have the 6 images. We do load, cyclic, complete folder, and we select our screw holder. And now if we run this, we see, okay, it's moving around in the field of view. If you run it with full speed, you see it's very fast. It's measure move. And so so the first step is now really how can we measure the part if it moves. The first thing is we should find the part. An easy way to do this is the key match. This is a matcher which you simply can give a part of the image, and you say, okay, you know, I'm looking for this part, or I'm looking for this part, whatever fits better. And the result is position orientation, and we can see if it works or if you have to adjust something. In most cases, it's okay. And if you run it, okay, we see not. I think you should adjust it to make it very stable. The other fast option in your case is, in this case here, is the block tool. You could say, okay, it's a bright part, which we are looking for. Here, this one here. And we want to remove all small stuff out of the image. And finally, we want to have some extended features. In our case, we want to use the eccentricity, which also generates a center point and an orientation point. This is what we need now for the moment. And if we move this, you see, we find the part always. This is a fast version where you don't have to think about a lot of stuff. So stop. So you can use the key match, or you can use the object the blob tool. Of course, you can also use the line segmentation or the particle inspect to find these parts. There are some other options how you can use which you can use, but for the moment, let's use this easy step. If you look to the different examples in our YouTube channel or on our Vision Academy, you find you see how it's explained to do it with the other stuff. And maybe for the other demo, I use the key match so that you see both in action. First of all, now we have at the end we have this object here, and we see the the position or orientation, and how can we use this to find adjust the caliper or all the other tools. Simple way is you simply use the result of the tool. And what is the result of the tool? To see this, you can, I showed it yesterday, you can use the data viewer for the value register and for the point register. And if you run it now, we see we have one object here, and we have one center point and one orientation point. So of course we have to add also the second point. Okay, save all, active sorting. And if we do now the same what I explained before, first of all, we show the coordinate system, and in the second step, we simply say origin and orientation clockwise, and we use it from the two registers. And now you see that the coordinate system is relatively to the coordinate system of the tool always at the same position. We could slightly adjust it. Oh. Okay. Yeah, so jetzt machen wir weiter hier. Yeah. Okay. We still have to adjust this one here. External features, display that angle display filter. Don't need the filter. Yeah. External features. Save object, point list. We want to have external access. We want to sort it. And okay. And the number of objects. Okay. So, and if we now use the caliper, an error. 1 second. So from pickup list. Position from pickup list. I thought I activated it. Features, width, height, distance, extended features, display, the axis, and I want to pick up all the points. Windows backup. So, order sorted by. Okay. For some okay, so for some reason I don't get the second value for the orientation, and as long as it's not stored, I cannot pick it up, and then I cannot use it. That means simply we go back to our caliper tool, to our key match, and start with the key match. Let's do this demo at a good image. That's exactly what I said. Either now we can simply use a live image from the camera and adjust the live image so that it works. As I mentioned before, if you do measurements, simply take care about the quality of the images, and although in this case it's not good. Normally you should before you use this but grab it. Okay. Okay, so test. Okay, interference. So we see here now you have a lot of crap inside of the part, which is not what we need for the detection of the part. So you have this option to eliminate it, or you do the, if you don't want to eliminate this stuff here, you could improve the light if your camera setup allows the light improvement. That's what should be the first way if you have this kind of image. Don't eliminate the stuff, simply improve the light. If you cannot improve it, of course, this is an option. And then we save it again. So we have this pattern, and if we run it now, we should see that the part is, if we move the part here under the camera, then we find it. So, and now we can go do the same stuff as before. We simply use the origin and orientation. In this case, the tool puts both values correctly on the point registers, what the object detection should do also. And if we run it now, we could simply draw the axis here, and use, if we move the part, you will see these axes will move with the part. Exactly. So, and we make it with live image. It's easier than the store. We could also store again the images, but I think it's not really what we now want to train, how to store images. The advantage is if you capture from the camera, you can always modify the capture parameters so that it fits to the quality you need at the end. So, and now you see here, of course, you see a lot of overlay now from the matching tool here. We don't need this overlay. We can simply switch it off only for the case. Let's use this one here. Then we see here, we have this measurement tool, and if I run the measurement tool and if I move the part, you see we do always the measurement at the same position. And as we did it before, of course we could also simply display the results of it. So we go to the communication section, use our communication tool, and print the result to our display, in this case directly into the image memory. So we say value, and we can move this value to this position. And now we see here we have this 106, and if we move it, because the caliper moves with the part in the right direction, we stay also if the part is rotating with the same 100.6 instead of what we saw before, because if you have a fixed caliper, the case how to get the edges are moving relatively to the measurement, to the distance measured here in the field of view. So the next step is, now we know how to do measurement in millimeters. The next step would be how to do the calibration. Therefore, we have different options, and depending on what you want to do, you could use the simple option, or you could do a more complex option. The more complex option, but which gives you some additional features, is the calibration based on a chessboard or a dot list. Though we have two nice examples for this. Today I want to do the simple calibration, and the simple calibration normally is based on the measurement of the part. That means, for example, you use a real caliper, or you use a golden part, as I showed it to you. Here you see now my caliper, and my caliper says this is 4 millimeters. This 107 pixels or 106, and we could use this to do a simple calibration. Why do we have this 106 and 107? So simple answer. Of course, depending on the quality of the lens, you have some lens distortions, and depending where you are in the field of view, the measurement differs a little bit. But we have to think about, of course, this is now not really a full pixel, it's 0.3 pixels, and this might be 0.0 millimeters. We will see it very soon. So the first step is to do measurement in millimeters. So this is what we saw, all pixels. Let's start with the way how to do the measurement in millimeters. Therefore, I simply do this, replace this program, do measure millimeters, of course, with movement, because we could also move the part as you saw it. And the first thing is we have to find out what is the distance of one, what is the dimension of one pixel. How can we do this? Of course, we need a calibration. Normally, I recommend to do it this way. You could do it also once by, the fastest way is now, you simply could say, okay, we know this distance are 4 millimeters from here to here. And of course, we know it's 106. So because we know this, we could say 1 pixel. We know exactly 1 pixel has the size of 0.03 millimeters, 0.0377 millimeters. So now we know how to calculate. That means if we see here, if the 6 changes to 7, the difference is 0.04, 4 hundredths. So when we measure now, or when we see moving, when we see this value is moving 1, or for 1 it's 0.04, 4 hundredths. That means we measure 4 hundredths difference for 1 pixel. So it's not so much. So, but how can we do it automatically? That's what we are doing now. So the first thing is we do a calibration. So let's use this. Save, calc, do measure in pixel, calc calibration, calc calibration. So, and how do we do this? We simply delete this stuff here. The calibration is easy done. If you normally you put your golden part under your camera, and you place it if you have for example you have a golden part, you have measured it, so now we know the part is 4 millimeters by let's see, I have to measure it by myself. So we have 4 by 9 millimeters. Let's put it here in the center of the image again. And maybe we move it a little bit in the center to make the training calculation. So 4 millimeters by 9 millimeters. That's what we have right now. The first thing is, of course, you put your golden part under the camera. Maybe you fix it to an attachment that it's easy to place it always at the same part. Of course, you could also use the key match. Then you can place it anywhere, whatever fits better. So let's say we open up this one again. And of course, now we have this one here. So we do the calibration based on the also on the adjustment, right? So we have to measure now this 104 and this 106 and this whatever it is. So and to calculate the real value. Therefore, we use, in this case, a caliper. We place it at this position. We do a test. Of course, I think we have to change to bright mode. And the next thing is because we know this one here is 106, we have to calculate what is the factor to calculate it in millimeters. And we do this by simply calculating the value. Therefore, we say we do some arithmetics, and we use a value type. So we have, as I mentioned yesterday, we have this value register. So we have a value type. This is the 106 point whatever. And of course, we use this from the register. But as I mentioned, the task is calculate the real world. We divide the real world, the 4 millimeters, divided by the pixel. So in this case, we need a value, and we need a manual value because we have this 4 millimeters here, and we do a division, and we do this division, what we measured right now here from the caliper. And if we run this, we see here we have 0.08. That's exactly what I measured, what I did done before. So this is our X value. So we have to remember it. How can we do it that we can use it later? Of course, you could store it in a variable, or you can save it on a file. Maybe you use different programs which you only have to do this calibration once. If the camera has moved, as long as the camera doesn't move, the calibration is still valid. So that means, okay, this is good. We can store it anywhere. And to do the storage, we can go to the communication part, and we say, okay, we want to store our calibration values. Calib value.ini. And our section is calibration. Maybe we want to store different things. And what do we want to store? It's the X, it's a Y calibration. And the Y calibration is in the value register 0. And of course, we want to write it immediately. So we use this value here from the value register 0, and we store it in a file, in a calib value ini file. And so we've done. So now we have the X calibration value in our file. If we have a look to our folder, project folder, we see here the data folder, and in the data folder we see now here, okay, this is our calibration value, the Y calibration value, right? And now we have to do the same for the X dimension, that you don't have to do everything. So we could move all the tools from here to the program editor, but we can also use the copy feature, which I showed yesterday, and copy the complete stuff here. Okay, this was, so copy, and what we want to do is paste. And in this case, we simply rotate the caliper to the X dimension. We see if it's measuring correct. That looks great. And the next thing what we have to change is, of course, this is the X calibration. And if we finished, we will see here, if you open up this one here, we have an X calibration of 0.0376. And of course, this is wrong, because you have also to adjust the calculation, because it's not 4, we know it's 9. This length is 9 millimeter. Of course, I measured this with the caliper, and because now we see in this image the threshold is not what we think is. We should say bright object, and it should be at least 200. And now it's more stable. So, and we run it now. And if you have now a look to it, you will see, okay, it's 0.376 and 0.38. Why I realized that I made an error, because most of the sensors have square pixels, and therefore only due to some lens distortion stuff, the calibration values should be nearly the same. And that was the reason why I realized, oh, I made anywhere an error, because this file should be, these two numbers should be slightly the same. So now we have these two numbers, and of course we can start the normal measurement in millimeters. For this, so let's store this as not do measurement normally, because do calib xy 2 millimeter, okay, with movement. That means we can do this calibration wherever the part is in the field of view. We can calculate the calibration that each time you have to move the camera or change the lens because the lens was broken, or change the camera, you have to run this program once with your golden part. Then you have your easy calibration parameters already ready. So, and based on this, we could start with some measurements. So we use the basic stuff from here and do now some measurements in millimeters. Do measurement in move. So we simply can delete this. And now, of course, our coordinate system is still in pixels. The next thing what we do is, what we now have to do is, we simply can load the calibration values. Therefore, we use the read from ini file, or we use the ini file, but with the read option. And yes, we use the ini file with the read option. So if you don't find it right away, it might sometimes a little bit difficult. You simply can enter the search. You enter it in the comments and in the search area. I mentioned it yesterday. Then the next step is you simply say load calibration, open this calibration file. Then after you have loaded it, immediately he gives you the contents of the file. The thing is calibration. Of course, we want to read it. And we want to read, let's say, first whatever, let's say the X calibration, and we want to read a value. We don't care about this section because we simply read the value which is there. So if we have done this, then we get the calibration from the ini file, and we need it once again. So either we move it from there or we paste it here. And because we now read the X file, we read the Y calibration value, and therefore we have both values here. If they are rounded, as you remember, in the file and also internally, we have it up to 8 digits, but here we store the last 4, and we still internally have the 4 digits for this operation. So we have first we loaded the X calibration, and then we loaded the Y calibration. Why is it so important? Because the next thing what we want to do is we do the calibration of the field of the image, and we do this simply by modifying the scaling factors. And so we have an X and Y scale factor. Of course, if you do it manually with your calculator, you could enter the value, but now we've done it automatically, and we want to use these values which we have stored. So first we read the X and then the Y. That means because we want to have the X factor. If you're not sure, so here you see the description of the tool. So first we load X and Y. Because we put it on the stack, this is when we read it first, it goes to register 0. And then when the next comes, then goes Y to 0, and this means it moves to 1. That means X is in 1, and register this Y is in 0. And now we want to also draw the coordinate system. And now if we, okay, now you see here, you don't see it, now the coordinate system is bigger than our field of view. But now the coordinate system fits to the measurements. And how can we test it? Simply with our measurement tool. We can use now the caliper, and we can adjust him to this position. And if we do a test now, we see we have, of course, bright test. And now we see we have 4.03. We said it's 4 millimeters, and we have an accuracy of 0.03. So if we run this now, we will see this value is moving a little bit, and we can also display it as we've done it before with the communication tool. If we put the communication tool in to the field of view, and we run this one, then we see here we have exactly what we saw. We have a movement of 1 pixel from time to time, and this is exactly 0.03 in the tolerance value. Yeah, if you have 1 pixel movement, you see this 1 pixel movement results in a movement of this position where we measure it. But at the end, in the measurement, it's 0.03. We are in the hundredths accuracy, even with this not so perfect setup. And of course, if we move it now, and we see we still stay on the 4 point whatever accuracy, depending on where we are in the image. As I mentioned, if we go to the edges of the images, like this one, this one, this one, if we are not in the center point, the accuracy is not so good. And yes. Okay, our problem is right now because we did object positioning before the calibration. This object position is no longer valid for this caliper here at this position. So we have to do it once again. Either we do the calibration before the object determination, or we do it once again after it. If you want to have a good solution, let's do it. Let's do this again. So we can delete this one, or we have to delete it because of the coordinate system. Then we can paste these 2 lines, and you see if it's still matching. Yes, still matching. If we activate the display, we will see it's matching. Okay, and the new modified coordinate system is now here. And if we use the caliper once again here at this position, we have to reset it and adjust it to where we want to measure it. As before, same thing. Of course, we have to adjust the brightness parameters again, and then we can add also our print for this caliper, yeah, value and so on. Moving this to this position, okay, and now you can see that we have a stable calculation value when we move it in the field of view. So the thing what you should have in the background, if you do this calibration, always first do the calibration and then do the rest of the stuff. Then it always works. If you see that it's not working, mostly you make a small error, as I did it right now when I simply added this the calibration to this program. As I mentioned here, I deactivated these two tools because here they make no sense. Normally, as I said, you capture the image, you do the calibration, and then you do all the other stuff. And of course, if you don't want to see all the stuff from the key match, you can say, "Oh, print it only if it's not working." Then you see only this from the key match, and this coordinate system is from this tool. So maybe you also deactivate it if you don't need it. Then you see only what you really need. You see here the result, the measurement, and not all the pre-calculations. So if the matcher is not working, it would be printed. That's why it's here red. So let's see. We calculated here this distance. Let's say you want to measure, for example, an angle, the angle between here and here, as an example. So how to do this? I would therefore we use these edge tools and of course the geometry tools to result it. So as always, you could do sometimes the combined tools, the probe line, or you use the rect probe. In the probe line is a combination of multiple tools. For today, I would use the single tools simply to explain how the software works, so that you can use then the combined tool, which makes life easier or program shorter. So how do we do this measurement? How can we calculate, for example, this angle here? First of all, we need an edge here, or we need a straight line where we want to measure, which should be used for the angle, and we need another straight line. To do this, we use the edge tool. Let's take this edge probe, and as for the let's say for the caliper, you have to place the edge tool where you want to measure it. So reset position, then you get the edge tool. You simply move it where you want to measure there, or you want to determine the straight line. In this case, let's say we want to do it here. And of course, because we are set to dark, we search a bright line. We can run it, and then we see here, these are the edges of the tool. So we don't care about this one. This is a special solution if you need one specific point. Now we get this edge line. How can we see that it works? Simply, you go to View, Data Viewer, and Point List. And let's go here and see some of this and this. And if you run this one, we see this is a point. These are the points from the edge tool. And as you can see here, we have here some red ones, and we have here some black ones. Why this? All these tools work as a stack. And of course, you see here it's moving down. And of course, this point list works also as a stack, and it adds all the new tools to the stack. In our case, in this case, we only want to use these new points. And in this case, we have to reset the point list. And therefore, we have this point list tool. It can do a lot, but it can delete the point list. And you see here, if you run the software until this point, the point list is empty, and the next are all the new points. This is what we want to have for our best fit line. If you forget, if you have sometimes, we have to look at it in a second. The next would be, we need a straight line, the best fit line through all these points. So you use the best fit straight line and you have it. And now you see this line. And why do we need to do a reset? Simply, if you don't do it, unfortunately, it's not enough. In most cases, we do have a lot of not usable points, and then this line goes not directly only through these points. No. Unfortunately, today it works very well. So you have to reset. This is important. If you use this tool here, the probe line, it does it immediately internally, so you don't have to think about it. But for some reasons, it's good if you can control and use the accumulation of points. We can discuss this later. So based on this, we have this edge point, and we want to have an angle. In this case, we simply use the same combination, and the only difference is now we want to have the points from here because we want to have a straight line to these points. Now we have these 2 points, and we can simply determine the angle between these 2 points. So we can say between straight line 1 and 2. So we use either the point register, the straight line register, not the point register. Here you can see it, straight line register. Or you could also use from pickup list. From pickup list means you can select, I want to have the first straight line here, and I use the second one from here. And if I do a test, we have 87 point whatever degrees between these 2 lines. It's not totally 90 degrees. Of course, this is based on the maybe not perfect angle of this part here. You see it's not totally fitting to this. Either we could improve a little bit more pixels in this direction. So one should know what is the real value to see if this is true or not. And here also the same, you can say I want to have it's red because the preset was not good. Now we use the last result, it's 87 point whatever, and we can say okay, 87 plus minus whatever, in this case 5 degrees, and it's green again, and we have this one. So of course the angle is independent of the calibration. Let's do something for what we need the calibration. Maybe we calculate the radius of this part here. In this case, we use the circle tool to do this. And to use the circle to calculate it, we need points for a circle. Therefore, we have the circle probe. And in this case, we simply use the circle probe, and of course we move it roughly to this edge. We put the inner probe to this position and the outer probe to this position, and because we are only interested in these values, so then we have to say, okay, we want to probe inward, but we want to see the bright part. And if we increase the resolution, we zoom into the image, we see here now, we see all these probe points. We have 52 probe points right now. And now we see what happens if we don't reset the point list. If we simply do this one here, and we calculate the best fit probe, and we want to have maybe the diameter of this, we see, okay, this is total crap. Why? Because you see here, there are a lot of other pixels which we really don't need for this calculation. So of course here we use also the reset tool before we do the probe point, and then we have this radius of this part at this position. And we see here it's also very stable. The result is the diameter. Let's see, we run it to this position and we have it on top. It's 1.32 millimeters. As the, oh, we didn't display the angle. So let's display the angle also here. We missed it. We say value. Of course, we can, that we know what it is. Angle, yes. And we have to display. It's here, so we can place it here maybe. So let's see. So angle 80.8, and of course maybe we can see here we can add also distance. Okay, and we have here the distance and the angle. You could put it also nicely to the field of view, and additionally here we can display then with the display tool also the diameter. Diameter, and of course we want to see it anywhere here. And therefore we have now these three values, and we can run it and we see, okay, the diameter is very stable. Of course, the distance has the normal stability and the angle is slightly moving. So we could think that this is dependent on, you see this best fit straight line, it's not, it's moving slightly. And this is one of the reasons why I said you should adjust the light and lens. Of course, here this edge is not very perfect. So either you can improve this edge anyhow based on light, or you say, okay, I'm good with this, or you take more points. So in the case of this edge, we could simply see maybe if we use more points here, and of course, because we see it's a very bright position, we increase this one here, and we run it, and now we see it's somewhat more stable. Now this line is moving slightly. We could do the same to stabilize this. So this was now a short overview, and now we do all the measurement in pixels. Of course, it also works as I didn't show it with after we did it. We can move the part wherever we want. We get these values at this, always in the movement. And so you see here your complete test program, depending on if you say, okay, here we didn't determined what is the correct result for this best fit. So we could also say, okay, 1.2 is 0.1 and 0.1. So, and now we could use for the caliper exactly the same stuff. We use 0.1 and 0.1 because we 0.1 because we produce it in 1/10 of a millimeter accuracy. We get here always good values. So of course we see here the distance is it's pink, you cannot see it. Maybe if some of the measurements are wrong, because whatever it happens here, then it would be nice to see which measurements are wrong. Of course, if the part is not so now we don't find the part. You see it. If we don't find the part, we see the we see it red here, and the key we see the keymat red. So you could say, okay, if I don't find the part, I do an error handling or whatever. But this is only stuff to be done for the program itself. If you work with real values, it's always nice to have maybe statistics. So you could make also a statistic with the software. We have different statistics here. One is the process capability. So let's say you want to see what is the difference in the distance of the caliper tool of the distance. You simply could add then the statistic process capability tool and add it here to the to this program. You say, okay, the value which I want to check is in register 0, because we have it here at this position in register 0. So we want to have 100, and the value should be anywhere between, let's say, 3.8 and 4.5, whatever fits well for you. And you can say, let's say distance. And if you run it now, you immediately get here the tolerance, and you see here the values are really stable within the 4 range. And of course, you could say, okay, I also want to monitor the radius here. Then you simply add the statistics to the radius. And at this point, the radius is also in the register 0. So it's really nice to have this register. So let's say the lower specification is 1, and the upper specification of the is 1.3. Maybe that's, and we say radius diameter, and now we have these 2 values here in the statistics. You can also reset the window and you get the values you see here. On top, the lower and upper specification for this one, and here for the radius, the lower and upper specification. And it runs, and you also get here the standard deviation, the CKP value, and whatever might be interesting for you to work on. So this was a short overview how to do measurement. Of course, I think you could imagine you can do any measurement based on all these tools, because you can measure. Of course, let's do some distance measurement. We did a distance measurement based on a caliper. Now we could, to show you also how to do a distance measurement with using a different probe. In this case, let's say the line probe. So we start the same way. We use this probe. Okay, we have to adjust it. Maybe we want to measure also from here. And we are looking for a bright object. Let's say the threshold is 200. And we immediately get a probe. So this is the advantage of this best fit probe. You get you don't have to do the reset and rect probe and best fit straight line. You simply have edited it in one. You can use the same one, the same tool. Of course, you could copy it also. At this point, maybe I've forgotten that. So, zack. So you could put it at this point and copy it, or you use it once again. You simply rotate it and you say, okay, I want to measure from here to here. Test. Oh, yes, we have to change it to bright object. And once again, we see it. Okay, this is for this area the best fit probe. And now we could say, okay, we want to have from this line to this point the distance. Therefore, we can use the distance to straight line or the direct distance. If you use, let's use the direct distance. So you can say point to point. In this case, he uses this point to this point. And you can say parallel to X or parallel to Y. In this case, it's parallel to Y. We use these 2 points and we get the value which is parallel to the Y coordinate system. And so we know the distance is roughly 9 millimeters, or we did it with a caliper, and we see here it's 8.91. It's exactly in the tolerance, I think, which we have. And if you see that the image is slightly not so good, we have here a very slight error. So we could adjust this either in improving the light or use more points to find a stable distance between these 2 points. So, but anyway, you see, you could do this distance measurement either with the caliper here. Of course, we could use the caliper and put it at this position, or we use these 2 probes. And why did I say, and we get, after we have calibrated the image, you get it always in pixels. This is important. That means, on the other hand, also, if you use the calibration version for the chessboard calibration or the dot calibration, it's exactly the same. The difference is only you use a different way to do the image calibration. And the real advantage of the chessboard and point calibration is that you also do correction of the lens distortion, which makes it much easier. Then you could also correct not so good lenses and measure in the complete field of view with the accuracy of the correction factor. So that's really the advantage of the chessboard or the point calibration. You do automatically an intrinsic lens correction. So for today, I showed you how to do measurements with the Ivision software. I showed you the tools, how to find the objects, how to do the measurements. And I really recommend that you simply have a look to demo projects. And especially here, if you go to measure and calibrate, and maybe if you're interested in the chessboard calibration, so you simply open up the chessboard calibration and you immediately get a demo how you should do it. First of all, so this is a demo how the calibration file is generated. This takes, depending on the CPU, a while. So this is you can see here it takes about 1.8 seconds to generate the calibration, and after you have the calibration, you need 11 milliseconds to do a complete distortion corrected field of view based on a chess pattern. So we can also give you some examples for chess patterns, or you buy one. You can buy it from most of the manufacturers of these kind of plates. And now you see here, we do this measurement within the complete field of view. Here, as I showed you with the stored images, here we use the key match also once again to determine the part, and we use the calibration, the distortion calibration based on a chessboard to do the calibration. Then we search for the object, and then you see here we do some rect probe measurements in this very small part. So that you do exactly what we did online today. You can see it here live. You can see it here as a demo. You see here also how to make these layout selectors, so to switch between programs and some other stuff. I really recommend that you have maybe a look to all these other projects. Also, for example, the search and measure, which is a more complex demo for what we made today. Means we have this part here, and but at the end you see here how we do the measurement. We do here you see how to do the calibration of the field of view, exactly what we did. A little bit more sophisticated based on a pattern, not on the real part. So you can do it as we did it today on the real part, or you do it on a custom print or part or glass plate, and so on. You have all these demos which shows you exactly which steps you should make to get your calibration, and then to do the measurement. And yes, I hope this was interesting for you today, and would thank you. And maybe we can see us for the next webinar very soon. And I would say thank you very much, and bye-bye. And I hope we see us soon again.